Okay, so we have tables for x squared and 2 to the x. We get the tables for the inverse relations. Okay? Now they're not both inverse functions because one of these is not a function. When you graph it, you get a graph that isn't a function. Okay? So this one is a function. This one is not a function. Because your graphs look like this. Okay, there's 2 to the x function. There's the inverse of the 2 to the x function. How can you tell that that's a function? How do you test to see if something's a function?
You just try it?
No, what's the definition of a function?
Doesn't have the same x value.
Okay? For any x value, you get only one y value. Okay? In other words, if I say what's x, you've got to be able to tell me what's y, right? Well, if I say, okay, x is 1/2, what's y for this inverse function? Well, if x is 1/2, y is -1. You see 1/2 over here anywhere else? So there's just one answer. Okay, at least for the numbers that we've got, and that turns out to extend. Okay? And how do you do that on a graph? That's called the vertical line test. How many of you have heard of the vertical line test? Okay, everybody knows about the vertical line test, right? You draw a vertical line, it intersects the graph at exactly one point. That's equivalent to saying if you made a complete table, every number over here would appear just once, or if you expressed it as a set. Because you can have redundant numbers in a table. But okay, that's a technicality. Okay, over here, okay, if x is 4, what's y? 2? You sure? Anybody have a different answer? Yeah, I could easily answer -2. You can't give me an answer. You got to give me 2 answers. Okay? And why is that? It's because when you graph this, you get a graph of a nice parabola here, and then you get a graph of that parabola. Well, it's not very well drawn. Turn on its side. Leveled it off too fast, but you get the idea. Your graph looks approximately like this, but yours looks way better than this one, okay? Right? Now, from the table you can see that there's not a unique answer to what is the value of y when x equals 4, right? There are 2 possible answers, just like there are 2 points on this graph. This one could have x equals 4. Your vertical line test fails. Okay? So this is not a function. Now this is really important if you're going to study math past pre-calculus, even pre-calculus. If you're going to study math past algebra 2, okay? You fix this by saying, okay, I'm just going to restrict this function by crossing out all the values that give me negative values of y. That gives me this part of the function.
Do you want us to draw this and like mark it out on ours?
I want you to what?
Do you want us to do this and mark it out on ours, or are you just explaining something?
You're- It's perfectly okay to do that and then cross out the part that doesn't, that you have to eliminate in order to make it a function. Okay?
Why is that not a function?
Why is this not a function?
What you marked out, yeah.
Well, what I marked out would be a function also. But when I have this combined with this, it isn't a function because 4 has 2 different y values. A function, if I tell you what x is, you got to be able to tell me what y is. You can't be giving me 2 different answers. And with this table, as it was before I marked this part out, for any of these numbers, you would have to give me 2 different answers. Now, having marked this out, I've eliminated that redundancy. So you have only one possible answer for every x value. And also now this function does satisfy the vertical line test, this branch, if I eliminate this. Okay? So we select one branch of the inverse relation. Okay? That's an extremely important action. Okay? Because inverse functions are a big deal. And when you do that, you know what function you have now? We eliminate all but one branch of the function, because you see this thing has 2 branches. It has a branch here, but it has a branch here that messes up your vertical line test, messes up the property this thing has to have in order to be a function. Okay, so we eliminate all but one branch, and we're left with the function is y equals x to the 1/2. Or square root of x. Does it work? What's the square root of 4? What's the square root of 1? 1. What's the square root of 1/4? Yeah, because if you multiply 1/2 by 1/2, you get 1/4, right? If that's not totally obvious instantly, pay more attention to fractions. Okay? As almost everybody coming out of our recent curriculum needs to do. Yeah. As soon as calculators started being used, people forgot how to do fractions as quickly as they could. Okay? Because you got to think a little bit. And you got some rules. They're not hard. But you don't use them, you lose them. Okay? Okay. Now, over here we got an inverse function, and this is an inverse function, right? Okay, this is a function. And namely, we got a name for this one. It's a log function. It's log base 2 of x. Okay? Now, if we did the function y equals e to the x instead of 2 to the x, the inverse would be the natural log function, that ln thing on your calculator. If this function was 10 to the x, the inverse would be the log function on your calculator. Okay? So it's worth Writing this down, hopefully it's something that we can see. Now, that's not everything you need to know about logs. There are rules and manipulations. I find in my pre-calculus classes, when I introduce them this way, and introduce the rules of logarithms, people do really well with it, which always kind of surprises me. But by that time, I've got, hopefully, people used to using the rules. They forget it real quick, but they can do it. They forget it because they don't have the right study habits to maintain it. Okay? And when I say they, some of them maintain it just fine. But as a class, you know, people do well on the first couple of homeworks, and then by the final exam, they've lost track of a lot of it. Okay? And that's kind of what separates my A's from my C's and worse. Yeah, just the characteristic. Characteristic A student remembers it. Characteristic C or less does anything from kind of remembers part of it to forgets the whole thing. Okay. Okay. So now you know what logs are, and you've constructed a graph that will allow you to estimate a log, right? So it's getting time to take a break. So we're going to go ahead and take a break until 11. Going to give you a good 20-minute break here. Okay? Freshen your mind, because we've been at this for an hour and 40 minutes. That's long enough. But when we come back, you're going to take the graphs that you've made and make some estimates. Here's an estimate of the log of 1.5. Here's an estimate of 2 to the 0.7. Because you got a graph, you can just make an estimate real quick, real easy. Okay? And then you can use your calculator to test your estimate. Make sense? Then you understand something about graphs that you probably understood when you came in, but understand much better now. Okay? Because there's an appropriate use of the calculator, because you have no way of calculating a natural log of any number except 1. Okay? It's always irrational. At least for any number, for any rational x, any of these logs is irrational, unless x equals 0. It's not hard to understand. We'll talk about it.